channel. Today we're going to cover a topic that's probably one of the most controversial C6Z06 topics out there, which is the LS7 valve guide issue. And today basically I have my next to bone stock Z06 here, and before I do any modifications to the car, I wanted to see where the heads were at, whether the valve guides and the valve clearance was within spec with what's in the tech manual, or if I have excessive wear. So today we're basically going to tear down the valve train and do the wiggle test to check the clearance between the valve stem and the valve guide and see if we have excessive wear. First thing we got to do before we get started is disconnect the battery. Alright, so remove the covers already, and next thing we're going to do is remove the spark plugs. Also put down some covers of the fender, just some beach towels to help protect that while we work on the vehicle. So upon initial inspection, everything in the rocker cover here looks pretty clean. Let's go check out the other side. We have all the parts laid out here on the bench. Alright, next thing we're going to do is remove the rockers, which is just going to be an 8mm socket, and just remove them in sequence, lay them out in order on the workbench. And now we're going to remove the lash caps, which are on the intake valves, and we're basically going to do that with just a pair of pliers. I covered them with paper towel and just give them a little wiggle and they should pop right off. Okay, so there's a couple of special tools you're going to need in order to complete this job. First being a valve spring compressor in order to remove the valve spring, the keeper, and be able to do the test. I ordered a compressor from LS7. This is a little bit of on the expensive side for sure. It costs 220 bucks. I know it may seem a little excessive and a little simple, but this actually will compress both the springs at the same time and will push down on the spring straight, not in an arcing pattern like a lot of them do where they sweep down, and that could actually score the valve stem if you make contact or something like that. So this will actually compress the springs down straight where we don't have to risk damaging the valve stem or any components in the valve train there. The next item is going to be a way to pressurize the cylinder to hold the valves closed. So I just ordered this, 10 bucks from Summit. The other items here, I got a test indicator, which is in a kit like this, and I also have a dial indicator here that we can use so I could show you the difference between the correct way how to do the procedure and the incorrect way. And I also have the stand here off a mag base and we're going to set that up in the cylinder head. So for this next step, I have cylinder 1 here at top dead center. I have my cylinder pressurizer line hooked up in the spark plug hole. I got my air pressure line from my compressor set at 90 psi. We're going to use that to hold the valves in position while we put the valve spring compressor on, remove the keepers, and that way the valves don't drop. So now I'm going to install this valve spring compressor here. So you can see here how it's installed. This bracket right here is notched, so you can slide it back and forth and make sure it lines up center on the valves. So right now I'm just going to tighten these down, and then we'll use this to compress the valve springs down. Alright. The keepers are loose now, so I'll pull those out with a magnet. We pull the springs out. And next we can remove the air. And then we'll be able to pull the valve seals out, and then we'll get the setup for the dial indicator. So next, just to remove the valve seals, just use a pair of slip joint pliers. Just grab on the outside and just lightly work your way up, and they pop free pretty easily. Alright, you can see now that the valves are free. They're just resting on top of the piston. And just notice, without putting my dial indicator on it yet, just pulling this up slightly, trying to wiggle it back and forth, I can't feel any play in the clearance between the valve guide and the valve stem. So let's get the precision measurement set up on this, and we'll actually get some hard readings. So I got the test indicator set up here. Hopefully I can get in here and show you guys the face of the indicator. So that's what I got for a reading. It's about 3.5 thousandths, just over 3 thousandths of an inch between going back and forth. Alright, I'm going to try another attempt to show you the reading here through the inspection mirror. You'll see there we're zeroed out, and there we're going to 3.5. Back again, 3.5. Back again, 3.5. I know it's hard to see through the mirror and lining it up so there's not a parallax, but it's 3.5 thousandths. Here's a page from the tech manual. We got valve, stem to guide clearance, service. We just did the intake, and there you got 0.0037. The reading we got was 0.0035. Alright, so here I'm going to show you guys the number 1 cylinder exhaust valve. I think I made a mistake when I first had looked at it, and it felt like there was no movement when I wiggled the valve, but now it seems to have loosened up and has a lot more play in it than I thought. Maybe there was some gummed up oil between the valve stem and the guide, and that was kind of keeping it rigid, but take a look at this now. Yep, that's way out of spec. That's like really bad. There's a ton of play in this. We're at like 12 thousandths. And we go back over here. Valve stem to guide, clearance, service exhaust. Yeah, 3.5, a little over 3.5, 3.7 thousandths. And we're at like 12. We're not even in the same decimal range. So check this out. I took the setup off. Look at the movement there. For something that's supposed to be 3.5 thousandths, you can tell without even using precision instruments that that is not good. So the intake was pretty close to spec. It was just below it, and this is way out. So just to update you, we just finished doing the wiggle test on the first cylinder, number 1 cylinder. The intake valve was actually within the tolerance. We got a number of 3.5 thousandths, and the tolerance from the tech manual is 0.0037, so we're 0.0002 under spec, which you're on the borderline there. You're pretty close to being out. And the exhaust valve we did, which initially I had just wiggled with my finger, and it felt really tight. It actually felt like there was no play in it whatsoever. And then when I went back and actually set it up with the test indicator, I don't know if there was some sludged up oil built up in there or something, and now it got loose, and now I could feel what the actual play is in it. And we were at 12.5 thousandths, so we're like 4 times over the permissible wear or clearance between the valve stem and the valve guide, which is really bad. So I don't even know if I'm going to proceed with testing the rest of the valve guide clearances, because I already know that that head has to come off, and be sent to a shop and have new guides pressed in. So what's the point of really continuing with this test if I'm just going to have to pull both heads off and have them sent out anyway? I don't know. I think we're going to wrap this up here, and probably the next video will be pulling the heads on the LS7 and having them send out for machining. So unfortunately, we kind of proved what everybody's talking about on the internet and the forums, previous videos, that the LS7 valve guide issue is very real, and it's something you should definitely inspect. My car has 22,000 miles on it. I bought it with 19,000 miles, so I've driven it 3,000 miles in the past year and a half, and clearly that was a risk I was taking the entire time. That should have been the first thing I did, was pull the valve covers apart and pull the rockers and did this wiggle check. But thankfully I'm doing this now before the engine blew up and there was catastrophic failure, because at least now I could just pull the heads, have them machined, and save the block, the pistons, everything like that is good to go. This engine was running when I pulled it in the garage here, so we really dodged a bullet with that one. So there's a couple things I wanted to talk about regarding the wiggle test, and one of the main reasons I wanted to do this video was because there's a lot of test procedures, a lot of people out there doing this incorrectly, and they're probably costing people a lot of money, and possibly their heads and their valve guides aren't bad, and because they're doing the test procedure incorrectly, they're getting a lot more wear or higher clearances between the valve guide and the valve stem, and they could be falsely telling people that, oh, their guides are out of clearance, they're out of spec, when in actuality you're just doing the test wrong, and those guides may have been fine, the head may have not been affected by that bad batch of guides. So one thing I wanted to go over was people are not disassembling the valve train fully, so they'll leave the springs on there and just take their finger and kind of just wiggle it back and forth. Well, that's not correct, because A, the spring is holding the valve in place, as well as the valve seals are still there, so you're not really going to get any kind of accurate measurement. You're not even using any kind of instrumentation to know other than just your finger. So that should just be obvious that that's not the correct way how to do it. The other thing I've seen that's incorrect is using the dial indicator at the top of the valve stem without using the calculations to offset that distance between the top of the valve stem and then where the guide is. So essentially, if this pencil was my valve stem and where my hand is holding is my valve guide, if I take my measurement with my dial indicator up here and move my valve stem back and forth, that distance is going to be a lot greater in its trajectory than if I was measuring here at the top of the valve guide, because obviously this distance is going to affect that motion, that distance there. So the correct procedure, you need to measure it down here at the valve guide as close to it as possible, perpendicular, and wiggle the valve back and forth, and that's going to get your correct measurement. But the way the heads are set up, you can't physically do that, so you need to use that instrument I use, which is called the test indicator. And that's the only way to test without doing the calculations, the small trig that you need to do to correct for measuring up here to make that measurement accurate down here. So for just a small drawn up example here, I drew a little valve guide, and this is kind of what that test indicator is going to look like. I know that's pretty expensive. I think I paid about $150 for the one I used, but I thought it was the best and most accurate way to do it. And then this angle in here needs to be roughly 12 degrees. That acute angle here is basically going to give you a direct representation of the valve stem to guide clearance, measuring just above the valve guide, so you know that measurement is accurate and there's no calculations needed. But if you're going to do this method with just a dial indicator, and because of where the cylinder head is, right about here, the top of it, you can't measure down here perpendicular with the dial indicator. The angle would be too acute for a dial indicator, but it's fine for a test indicator. So you need to do your measurement up here, but now you have to account for this additional length that you're measuring at the top of the valve stem instead of at the bottom here at the guide. So you need to do that basically right angle trig calculation to represent what the actual clearance is here. So you can't just take the face value of the dial indicator. That is going to show a much larger wear than what it would be if you were to do the offset calculation for the measurement down here. So thanks for watching this video. If you want to follow more of what's going on with my C6Z now that you have seen that it's failed the wiggle test and basically what I'm going to do to correct that issue, I want to move forward with this car and start doing some modifications, but obviously this is going to be the first step. We got to have a reliable valve train before we start doing any other work, because this engine effectively was a time bomb waiting to go off, and thankfully I caught it before the valve stem snapped and the valve dropped in the cylinder. Then boom, there goes the block, the piston, the head, everything. But we caught it early. The engine was still running. There's no damage to anything, so we're looking really good right now. I could send the heads out to get new guides put in and have the seats remachined. I'll probably go with the upgraded stainless steel exhaust valves, have the intake valves polished, bronze guides put in, and I'm also going to do upgraded springs because I want to do a cam in the car. So if you liked the video, I hope this really helped you out. If you have a C6 Z06 and you haven't done the inspection on the heads, definitely use this video and hopefully you can knock it out yourself, and be mindful of the test procedure and the correct way how to do it. And if you are bringing it to a shop, make sure they are following that correct procedure. They could be trying to sell you to have your heads remachined or new heads put on or whatever the case may be, and you may not need it. But obviously in my case, I proved with the wiggle test that my guides are bad and I need new ones. So if you like the video, give it the thumbs up, subscribe. Trying to get this channel off the ground and rolling, and we're going to do more car videos, more engine videos and stuff like that. Transitioning out of my current job, which I work overseas all the time as a marine engineer, and now that I'm going to be stateside, back at the garage more, I should be able to continue updating and doing more videos more often. So thanks for watching.